Okie dokie, Algebra, Chapter 6, Section 6, Solving Exponential Equations. Good times. The property of equality for exponential equations tells me that if I have the same positive base, or also that's not 1, so the base is not 1, okay, then the exponents have to be the same if the powers are equal. So in an equation, if the powers are equal and the bases are the same, the exponents have to be the same. Okay, I can use this to solve exponential equations. So if it says that it's equal like it is here and the bases are the same, then I can set the exponents equal. X plus 1 is equal to 5. And then I can solve that, subtract 1 from each side, x equals 4. Okay, here again, we have the same bases. The exponent here, there's none, so there's a 1 implied. So 1 is equal to 2x minus 3. And then solve that, add 3 to each side. Add 3 to each side, add 3 here. And then I get 4 is equal to 2x. Divide by 2 on each side, and x equals 2. All right, again, we have the same bases, so we can set their exponents equal. 3x is equal to 2x plus 3. And now we have a variable term on each side, so I'm going to subtract the smaller one. Minus 2x. That cancels out. I get 1x is equal to 3, or x is equal to 3. Now, if their bases are not the same, my goal is always to find a base that's the same. So I'm going to try to rewrite 125 with a base of 5. So I have 5x is equal to, well, 5 to what power gives me 125? 5 to the third power, right? So I can set that here, 5 to the third power, and therefore x is 3. In this expression, I have 4 to some power, and then 2 to some power. Well, I need the same base here. So how can I make 4 be a base of 2? Well, 4 is also 2 squared, but it has an exponent of x, so I have to do 2 squared times x equals 2x minus 3. And then I get 2x is equal to x minus 3. Add 3 to, I have a variable term on each side, minus x on each side. Now I'm not going to cancel out the x. This is minus 1x, so it leaves me with x is equal to negative 3. Over here, I have 9 and 27. Well, 9 squared is not 27. I can't do 9 to any power to get 27. I can't break this up, but I can do 9 and 27 both have a power of 3 in them. So I could do 3 squared, and then we still have the x plus 2 here. And then 27 is 3 cubed, and we still have that x there. So now I have 2 times x plus 2 is equal to 3x if I set their exponents equal. So that gets me 2x plus 4 is equal to 3x. I'm going to subtract the smaller variable term, minus 2x on each side. That cancels out. Now I get 4 is equal to x. Okay, and then finally solving equations where b is between 0 and 1, where b is a fraction. Okay, so my goal here is again the same thing, to write these as two expressions with the same bases. Okay, if I have a half, remember that a half, 2 I can write as 2 to the first power. And if I have this in the denominator, I could also rewrite that as 2 to the negative first power. So now I have a base of 2. So I could rewrite the 1/2 here as 2 to the negative first, and then I still have the x, so times x. And then over here, the 4 can be rewritten with a base of 2. 2 to what power gives me 4? 2 squared. So then I have negative x is equal to 2. Multiply each side by negative 1, and I get x is equal to negative 2. And then here I have 4, and there I have 64. Well, 1 over 64, is there a way to get 4 or 2 as a base? Well, 4 to the third power is 64, so I can rewrite this as 1 over 4 to the third power, which is also 4 to the negative third power. So now I have 4, x plus 1, and then 4 to the negative third power. And now I can set their exponents equal. X plus 1 is equal to negative 3. Subtract 1 from each side. And x is equal to negative 4. And there you have it, ladies and gentlemen. Solving exponential functions is lots of fun, good times. Oh yeah, check in again next time for another fun lesson.